Right, well, today I think I will be doing something actually programming related, and it's going to be very simple, because if I make it too complicated, I'll just screw it up. A simple little program that demonstrates an idea of particles, very basic. Obviously, the first step would be to set up the rendering code. So we will plop in a picture box. Alright, change some of the properties here. Particles, background colors, change it to white. Leave most of everything else unchanged. A tad bigger there. Alright. Now we need a class to hold the global stuff, the program state. Right now we just want a set of particles, but first we need to define a particle class. Particle's pretty simple. Location. Location. Some setters and getters. Now, one might wonder why I'm not just using automatic properties, and that is a good point, actually. Never mind that, though. Right, so we've got a location. What else would a particle have normally? Well, a velocity, obviously. We do the same thing for that. Alright. A few pastes here, and there we go. So it's got location and velocity, and let's define a few methods that can be used to tell it what to do. Public void perform frame program state PST. That'll be for program state there. Right now it'll just do what you might expect. Skip keyboard. Location.x plus velocity.x. Location.y plus underscore velocity.y. Got the underscore on that first one now. Alright, there we go. That should fix that. It needs to draw public void draw graphics G, and let's just draw a box at the location G dot fill box. What was it? Oh, fill rectangle. That's right. Solid brush. Color that red. Go with location.x, location.y. -2, and then have width of 4 and height of 4 respectively. Okay, that should be a good basic particle class there. How about while we're here, we'll make the velocity decay. Very slowly, it'll slow down, so the particles won't just go flying and disappear over time. But oh right, actually, that's a good point. Constant to live equals pivot times 10 living out equals 8 times 10 0, 0. Let's say it lives for 3 seconds. Alright, planet, date time, birth time. Alright. Make that nullable. And if birth time equals null, birth time equals datetime.now. And we'll change that to return a bool. If it returns true, then the particle needs to be destroyed. Return datetime.now minus birth time is bigger than live time. So if that's bigger, then we need to die, basically. It's unfortunate, but you know, it has to be done. Right, program state will basically have public list of particle Alright, particles equals new list of particles, awesome. Now this needs to initialize some important stuff here. Private thread game thread. Why yes, that is what I'm using, thank you. Visual Studio for actually not being stupid. Wait for game clock. If we run in routine. Alright. Private games. Program state p state equals new program state. Alright, and game clock would just be an empty loop, while loop. For, I'm doing that one for. Alright. The for loop that basically just goes through every single for each particle p in p state dot particles. We just go through each particle. P dot perform frame, perform the frame. Oh, and if p dot perform frame returns true, then we will add it to another list. Like that. And oh, right. You send in the p state there. We'll add it to the removing particles. Remove particles dot add p. And then once that loop is done, we basically go through it again and remove all the particles for each p remove and remove particles. And we go ahead and remove them. P state dot particles remove. Remove. The reason why we're not actually moving it here is because if we do that, we'll get an error because it's being enumerated for each while we're in here. So we have to basically defer that to after we're done processing it. Then after it processes it, we'll make it update the frame. Begin invoke. Actually, no, invoke. Method invoker. How does this work? Oh wait. Pick particles dot update. Pick particles dot. I think that should be enough. That should be enough. No. Pick particles dot invalidate. And then pick particles dot update. We have to make that a code block, I think. and I think that's valid. Or not. Oh, right. That good? Thank you. Thank you. About time you realized my obvious genius. Alright, go back to the form. Need to manage its paint event. Basically, in the paint event, we loop through the basically like before. Particle p in p state dot particles, and we basically paint each one dot draw to e.graphics, and that's pretty much the end of that one. Now we need a way to make it so it actually saving obviously. Now we need a way to make it actually create particles, which shouldn't be too hard really. What we'll do is make it handle mouse down, push mouse up. Mouse click actually, that makes more sense. And pointf quick location equals e dot location. Oh wait, is that like a normal point structure? Yeah. Okay. E dot location dot x, e dot location dot y. Now we create a new particle. Particle create particle equals new particle. Okay, it should have like constructor there. Sorry. I forgot to make constructor. With pointf location, pointf velocity. Now I'll create a static function. Public static pointf create random vector float speed. Should create a random pointf vector obviously of a given speed. First we select the random angle. Public static random rg equals new random. Alright, rg dot next double times math dot pi. So random angle, double random, actually no, make a float. Float our angle equals float of that. And, okay, this always gets me. There we go. There's the random angle. We just need to do, guess what? Create the vector. Return new point. No! Oh, pointf. Oh, is it cos or sine? Our angle times speed, math dot sine of our angle times speed, and we need to convert that to a float, as well as this. Alright. So trick, now we will say public particle pointf location float speed, and we will just call the base constructor, the other constructor with the location and the random vector of the given speed. And that's pretty much it for the constructor. Obviously we need to initialize our type variables to the passed in parameters. But aside from that, that should do it. And oh, whoops. There. That would explain why the IntelliSense was giving me that weird thing there. No, what was I before I got sidetracked? Oh, yes, of course. We will say quick location, and we'll say the speed is say something crazy like 5, some random value. And now we add it to the state variables. Alright, now that probably won't work. In fact, it will probably, oh yeah, you know what we need to do? We have the game proc, we have the thread variable, but we're not creating it. That is rather troublesome. So in the load, game thread equals new thread. And we'll make the starting game clock, obviously. What are you talking about? No, capitalized it. I'm doing this for ages and I still use capitalization wrong. Anyway. And let's see. I guess we can start it here, although I don't think that's right. Start. Alright. Save it all, and we'll see if this works, which it probably won't. Oh, do you see that? Awesome. That's like going way too fast though, so. Oh. That's trouble right there. Oh, you know why? You know why that happened? The thread still runs after it closes. So we'll fix that by just going in here. Going to unload, I think is event. Why do I not know what the event is called? Oh wait, I think it's closing is what it's called. Yeah, phone closed. Actually, no. What we should do is phone closing. Should just say it out loud, obviously. Because we want to do it before it closes. Game thread abort. Game thread equals null. And that'll raise an exception in the game thread, so we need to plop the whole thing in a try catch. Catch thread abort exception ex. Print game thread aborting. Alright, yes, thank you. And I think what we'll do, what we should do is two things. First, we need to add a delay here. So say sleep for, oh wait, thread.sleep for, let's say 50 milliseconds. You'll change the speed so it's not giving it like 5 or 6 or whatever I was giving it. Oh, and also, for int I equals 0, I smaller than 50, I plus plus. We'll do it 50 times. Make the speed 2 or something. And let's see how that works. That's not random. Oh wait, yes it is. For some reason it's not going. Yeah, it's broken. Oh wait, because the speed's not negative maybe? I don't know. Okay, well let's try something. Oh wait, you know why? It's because this should be multiplying it by pi times 2. Oopsie daisy. Let's say speed times equals x double. Well, we'll cast it to a float. Otherwise it probably complains because it's freaking whiny. And there you have it, some beautiful particles there. And, you know, it crashes, it's cool too. How was it modified? I totally have that in a separate thread. Oh, you know why? It's because the game clock is on a separate thread from the UE thread. So this one is invoking that, so we'll just lock it, I guess. Lock on pstate.particles. Alright, and we'll do the same thing here, so they'll now both hold it at the same time. on pstate.particle, no capitals, .particles. Alright, and close that, and there you have it. That should solve that little issue there. Boom! Boom, 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 boom. It's fireworks of excitement. That's kind of the core idea of base blocks particles. It's more complicated, but you know. There's alpha. Let's add alpha right now, actually. Should be interesting. Which is in the draw. What we want is we want to create and get the alpha value so we can use with the color. In fact, let's make that a variable. Particle color equals color.red. There we go, pumps out there. Changes to particle color. Well, not really. Color, use color equals particle color. Now I need to calculate an alpha value. It's an integer, so from 0 to 255. Basically, percentage through, what is it? The percentage of live time that datetime.now minus birth time is. So we want datetime.now minus birth time divided by live time. Take the milliseconds. Int ms live time equals datetime.now minus birth time dot. But that should totally be giving me a time span. That value dot total milliseconds. Alright. But hey. Fine. Double. What total milliseconds be double? No matter. Double. Lifetime equals date time equals live time, I think it was. Yeah, live time. About total milliseconds. And double percent life equals this live time divided by lifetime. And we want int alpha use equals integer representation of percent life times 255. But yeah, 255 minus the int of that. I should probably do that. And use color equals color dot from the RGB. Alpha use particle color, and we want to use color instead of particle color right here, and ta-da! That probably won't work, but you know, at least I can say I tried. I don't mind, it does work. Because I'm a genius, that's why. Alright, fading particles of excitement. Oh yeah, that's some exciting news right there. So yeah, that's a basic little tutorial on creating particles. As you can see, now closes properly as well, which is helpful. I hope this, helps somebody somewhere at some point in time.